Hello and welcome to the start of a brand new Unreal Engine 4 tutorial series covering how to make a real-time strategy game. So I'll be using some assets that I've pre-purchased and pre-bought and ready to use for the tutorial. And if you want to play along with what I'm using right here, I'm going to put the starting project files for this available on my Patreon for Gold members. So Gold Patreon members can download this and start playing along with me and working on the project as we go through this series. Otherwise, you're more than welcome to use any pre-built assets you have or any just mannequin stuff. Totally up to you. It will work for that as well. But there's that offer there for you. So in this first part, we're going to go through and set up our game mode, our player controller, and our camera for real-time strategy gameplay. So let's get started. The first thing we want to do is create the game mode. So we can go to Add and choose Blueprint Class and choose Game Mode Base. And in there, we're going to call it RTS Game Mode. And we'll then want to go into Add Import, Blueprint Class, and choose Player Controller. And this one will be called RTS Controller. So we need to tell our game mode here to use this controller. So open up the game mode and tell its Player Controller here to be RTS Controller. Hit Compile and Save. And then we have to tell our game here to use this game mode. So go to Project Settings, Maps and Modes, and default game mode is RTS Game Mode. Make sure that is still RTS Controller here. And that's now set up. Now go into your RTS Controller, and we're going to make some custom things in here. The first thing we're going to do is we're going to tell on Begin Play that we're going to set the input mode to Game and UI. And in there, we want the player controller to be self, because this is a player controller. And we want to change the in-mouse lock mode to lock always. This clamps the mouse to the screen, so it doesn't go outside the screen, which is important for when we're making cameras. And we're going to turn off hide cursor during capture. Then you want to go to class defaults at the top, and we're going to make it so we can see the mouse cursor at all times by clicking show mouse cursor. Whilst we're here, we'll also need to enable click events for later on in the series. This enables us to click on actors to select them. So we'll hit compile and save here. So next we need to work on our camera, and this is where the brunt of the work's going for this episode. So to get started, let's create a new blueprint class and choose actor. And this is going to be called RTS camera. And on the camera, we're going to put in a spring arm. And attach that spring arm and put a camera. Like so. I'm going to select my spring arm here and I'm going to rotate it so it's in the air looking down. Maybe 70 degrees. It'd be better. There we go. And then I'm going to change the target arm length here from 300 to 5,000. Okay. Hit compile and then go to the event graph. So on our camera here, we need to tell it to update and change where it's going at all times. So first thing we're going to do is make it so it uses this camera. So on Begin Play, we're going to right click and get Player Controller. And from the Player Controller, you can use a node called Set View Target with Blend. Plug it into Begin Play. What this will do will tell the controller to focus the camera through another actor based on their camera position. In this case, the new view target is going to be itself. Plug that in and leave it as is. We don't want to touch anything like blend time. That affects how the transition is. We want to just cut to it. So 0 will make it cut to this camera. So the next part is to get all the movement working. So the way it's going to work is that when your mouse approaches to the edge of the screen, it will speed up and move the camera to match it. So in here, we're going to make a new function here called move left. Okay, and this function is going to handle the moving of the camera to the left of the screen. So to get started, we need to get the mouse position on the viewport. You're then going to split that return value because we need just the X value to do the left axis. And alongside that, we also want to get the view size. So get viewport size. We might not actually need this, but yeah, no, we will need it. Sorry, my bad. And then what we'll take is we'll split that again because we only need the x-axis, and we're going to take the x-axis from our position viewport and compare it to a percentage of our viewport size. So I'm going to take the value x here and multiply that by a float and multiply it by 0.05. So that gives me 20%. So 20% of the screen is going to be where the mouse will move the camera. So I want to put this into a range, a normalized to range. And the normalized to range takes a value, in this case the mouse's x position, and looks at how it fits in between a range here. So range min, 0, range max, this value. If it's closer to 0, the normalized range will be 0. If it's closer to the max, it'll be closer to 1. So this is actually inverse to what I actually want to achieve, because I want it to speed up as it gets closer to 0 rather than speed down. So what I'm going to take here from return value is just do 1 minus. So I'm going to do float minus float. And I'm going to put that into the bottom one and do 1, and it'll do 1 minus this value here. Basically giving me the inverse of what we have here. Once we've got that, I'm going to multiply this by a vector. Float by vector, there it is. And I'll move it in the x coordinate by 100. Like so. We're then going to set the position of this camera by adding a position to it. So I'm going to go over here and go add relative position for the default scene route. And you're going to drag that delta onto it like so. So that's the move left function. Hit compile and save that. Go into your event graph, and this will go on tick, because you constantly want to check whether or not you're moving left, right, or up and down. So I'm going to drag that out and hook that up to tick. So now we need to position our camera. So drag it out into the world. And the thing you want to first of all do is, I noticed that the collision is ticking it on. So what I'm going to do here is just turn off collision settings on my spring arm by doing do collision test false. Okay, so now that's in the world, we want to make sure it's facing the correct location. So at the moment, X is going that way, which is not what we want. We want X to be going that way. So I need to rotate the camera in the Z-axis here by 90 degrees. So now it is going in the X direction, which is X is to the left here, which is great because that's what I just did the code for to make it move left. So X is that way, Y is that way. Okay, now we're going to go back into our RTS camera, onto the move left function, and I'd realised we haven't clamped our normalized to range here. So we're going to take our normalized to range here. Before we take it away from 1, we're going to clamp it. Oh, not clamp angle, clamp float we want. Clamp float, and plug that into the 1 minus. That way we don't get any value smaller or larger than 1. Hit compile and save that. And now let's push play. So you can see there's our game here. If I move the mouse to the left, you can see it scroll to the left. And you can see how it speeds up as I get closer and closer to the edge. So now move left is working. We want to get it doing for move right. So we're going to duplicate move left. So duplicate that and call it move right. Now it's very similar to the other one. So we just need to change a couple of things here. First of all, we need to change the value here for the multiplier to 0.95, so it's 20% off the other end, so 995, and that will now be the minimum, not the max. The max will be the return value from the get viewport size. Okay. Then we want to take out the 1 minus and get rid of that, and plug that straight into our vector. And the vector is going to change from 100 to minus 100 because it's going the other direction. Hit compile, go back to the event graph, and drag move right onto the tick. Now if we just push play, if I move the mouse to the right, it moves to the right. If I move it to the left, it moves to the left. Okay. So now we have to worry about up and down. So up and down, again, are very similar, except for the axis difference. So I'm going to take move left here. I'm going to duplicate that and call that move up. And on move up here, we're going to take the x-axis and move it to y-axis. We're going to leave it at 0.5, but we're going to change the y-x to the y here. And we'll keep all this the same, and then we just change the vector here from 0 to x and then 100 in the y. And hit compile, and that's move up done. So drag that in and see how that works. Compile, save, and let's test that out. So now move up. The camera move up. Left, right. So lastly, we just got down to do. So again, just duplicate move up, duplicate that. Move down, we'll call it. And the difference is, similar to how we've done with the right hand side of the screen, we're going to do 0.95 here. That will become the minimum. The maximum will be the y-axis straight plugged in like so. And we take out the 1 minus, plug it straight in, and that becomes minus 100. And hit compile. And that's it, I think. Yep, that looks like it. So go to the event graph, drag move down, and hit compile and save. So now we've got a camera which scrolls to the left, scrolls to the right, scrolls up, scrolls down, and can also do diagonals as well because it'll both be true, so they'll both move. And we now have an RTS camera. Okay, brilliant. So and that's it for this part. If you enjoyed this video and want to see more, head over to patreon.com/RyanLady where you can watch the second part to this video, plus many more videos well before anyone else. Big shout out and thank you to all of my patrons. Without you, this series wouldn't exist, as this was one of the goals on my Patreon. So thank you again so much for your support. If you're watching this video and you have yet to subscribe to the channel, please hit that subscribe button. I'm releasing videos every day, and as well as live streams. There's so much content you don't want to miss out. Thanks for coming, and I will see you next time. Bye everyone.